So we have started discussing about the method of consistent deformation in the previous lecture. Now here, if you look at the procedure of the method is described in this slide. If you look at the procedure one by one, we can see we will first of all find out the degree of static indeterminacy of a structure. Let it be a rigid jointed frame or a pin jointed frame. The first step will be to find out the value of ds. This is ds, degree of static indeterminacy. Now, as a second step, we will identify the redundant forces or unknown forces in the structure, as we have seen in the previous example. Then we determine, a determinate structure is formed by removing those redundant forces, as we have seen in the previous example. Further, translations or rotations due to external forces are determined along the directions of the redundant forces in the released or determinate structure. Again, translations or rotations due to the redundant forces are determined considering the redundant forces just like external forces, and we are going to get these displacements, that is translations and rotations, in terms of the unknown forces or redundant forces. Once we do that, we can apply the compatibility conditions available from displacements or from geometry to determine the unknown redundant forces. That is the procedure. Well, once you find out these unknown forces, we can apply the equations of equilibrium to find out the other forces. For example, the other reactions or bending moments or shear force. If I go for an illustration of a continuous beam, with several supports like that, with some forces, maybe UDL here, a point load here, several point loads here, like that. The deflected shape of the structure would be, maybe it can be like this. Like that. The deflection or translation at these joints are prevented. So these joints will give us compatibility conditions. If you find out degree of static indeterminacy for the structure ds, this will be equal to 3 times number of members plus number of reactions minus 3 times number of joints, that is equal to 3 into 3 members plus reactions 3 plus 1 4 plus 1 5 plus 1 6 number of reactions minus 3 into number of joints 1 2 3 4 joints into 4. This will be 9 plus 6 minus 12 equal to 3. So the forces at this support, reactions at this support, and the third support can be chosen as the unknown forces. And the compatibility conditions, we require 3 compatibility conditions, would be the deflection at this joint. Vertical deflection at this joint is equal to 0. Vertical deflection at this joint is equal to 0, and vertical deflection at this joint is equal to 0 can be chosen as the compatibility conditions. So if we solve for those 3 equations simultaneously, which are in terms of the reaction here, the reaction there, and the reaction there, if we follow the procedure properly, we are going to get those unknown reactions. Once you get those unknown reactions, we can go on finding out the other forces. Well, if you illustrate further, if the reaction here, let us say that is R1, this is R2, and this is R3. The displacement at this joint, when you remove all these 3 reactions, is equal to say delta 1. Displacement at this joint, when you remove the reactions, is say delta 2. And displacement at this joint is delta 3. So these are the displacements at these 3 joints respectively when all those unknown forces are removed, when the structure is statically determinate. Now, the displacement at this joint, when we apply a unit force along this R1, then that be equal to delta 1 1. That is the structure with only external forces, the same structure with a unit point force along this R1. In this case, the deflection here can be named as delta 1 1. Deflection at, say, joint number 1 due to a unit force along joint number 1. Now, due to the force R1, the deflection is R1 into delta 1 1. When you apply a unit force over here, the deflection at this joint would be delta 2 1. Deflection at, say, joint number 2. That is joint number 1, that is joint number 2, this is joint number 3. And deflection at joint number 2 due to the application of a unit force along R1, that is delta 2 1. So total deflection at that joint would be equal to R2 into delta 2 1. Likewise, deflection under joint 3 due to unit force at joint number 1 can be termed as delta 3 1, and the deflection due to the force R3 would be R3 into delta 3. So when you apply a unit force along the direction of R1, we are going to get a deflection of delta 1 1 along this direction, a deflection of delta 2 1 along this direction, and delta 3 1 along the third direction. So total deflection due to the force R1, if you replace 1 with R1, would be R1 delta 1 1, R1 delta 2 1, and R1 delta 3 1. Similarly, if we apply unit forces along the directions of 2 and 3 successively, say like this. Unit force at point 2, this is point 1, that is point 3, and further unit force here, this is point 1, that is point 2, point 3. The deflections along point 1 in this case would be delta 1 2, deflection along point 2 would be delta 2 2, and that along point 3 would be delta 3 2. As a general rule, we can say the deflection along a coordinate, the coordinate is given, say, the first suffix, and the point where the force is applied is given the second suffix. That is fine. So likewise, we can find out the deflection due to forces R1, R2 and R3 along all these three junctions, and finally we can apply the compatibility condition like delta 1 plus R1 delta 1 1 plus R2 delta 1 2 plus R3 delta 1 3 is equal to 0, because the final deflection here is equal to 0. And second compatibility condition is this, and the third compatibility condition is this. You can see that this is a set of three simultaneous equations in which R1, R2, R3 are the unknowns. So a solution of these three equations will give the values of the unknown forces R1, R2 and R3. Once you find out them, you can go back and find out the other reactions.